Hello everyone, welcome to my channel and welcome to another video on integration. And in this one I have a combination of the exponential function and the trig function. So we have to evaluate the integral of e to the power x cos 2x dx. Now as you can see, the combination of two functions, perhaps the best approach would be to use what we call integration by parts. So we approach it as follows. It's the integral of e to the power x cos 2x dx. Now using integration by parts, like I said, we're going to let u be equal to e to the power x, and then we have to have dv. Remember, integration by parts, we have to have dv, so this being equal to u, and then this part here will be equal to dv, so it's cos 2x dx. Now we differentiate u with respect to x. Du dx is just e to the power x. Remember, derivative of e to the power x with respect to x is just e to the power x. Multiplying by dx both sides, you're going to get du is equal to e to the power x dx. On the other side, we have to integrate both sides. The integral of dv is just going to be v. The integral of cos 2x, you would recall from my previous videos that this is just sine of 2x over 2. Integral of cosine is positive sine. Integral of sine is negative cosine. Derivative of cosine is negative sine, and derivative of sine is positive cosine. Remember those aspects. Now the formula for integration by parts says the integral of u dv is equal to uv minus the integral of v du. Now notice this part here is that part there. So we are basically saying this implies the integral of what is u? E to the power x. What is dv? Cos of 2x and then dx. This must be equal to, I'm here now, what is u? U is there, e power x. E to the power x, that's that part. V is this expression, sine of 2x over 2 minus the integral of v, it's this one, du is that. So basically I'm saying sine 2x over 2 times e to the power x dx, like that. Let's rewrite this expression here and that part. If I move backwards a bit, I'm going to say this is half of e to the power x sine 2x. That's that part. And then coming this side, you'll agree with me that this is just take half out, because the constant integral of e to the power x sine 2x dx. Fantastic. Now moving on. This is page 1 actually, not just page 1. Let's go to page 2. So now what I'm going to do is the following. I'm going to let that part be equal to some integral I. So this is going to be half e to the power x sine of 2x minus half I. I have to evaluate what this integral on its own. So I is going to be the integral of e to the power x sine of 2x dx. Integration by parts again. I'm going to let u be equal to e to the power x, and remember you have to have dv on the other side. Dv will be equal to this part, sine 2x dx. Differentiate one side, integrate the other side. Here, if I just go straight, you'll agree with me that this is just du is equal to e to the power x dx. Right, on the other side, the integral of dv is v. On the other side, we're going to have, remember, the integral of sine is minus cosine, so this is minus cosine of 2x, but we have to divide by 2, like that. Now, integration by parts formula, the integral of u dv is equal to uv minus integral of v du. Now, this part here, you agree with me, that part there. So this is the integral of e to the power x. And then what is dv? It's sine 2x dx. Sine of 2x dx is equal to, I'm here now. What is u? E to the power x. V is this expression here. Minus sine, it's actually cosine. Minus cosine. I'm going to try and fix this part here. It's that expression there. So it's minus cosine, minus cosine, right, that's fine. Minus cosine 2x over 2, that's v, and then minus the integral of v du. V du, so v is this one, du is that part. So v is minus cos 2x over 2, that's v. Du is e to the power x, e to the power x dx. Remember, e to the power x dx. Right. Now, I have to clean up here. It doesn't look nice. I'm moving back a little bit to create space for myself. This will be, if I move back, it's going to be, take minus half out, minus half e to the power x, and then we have cos of 2x. That part is taken care of. And then I'm coming to the other side. Remember, there's a minus, so we take the minus out, it becomes positive, and we have half. So positive half, and then we have the integral of e to the power x cos of 2x dx. Fantastic. So this is our I. I'm going to take this expression, bring it into that place there. Remember where we're coming from. We're coming from this part here, the integral of e to the power x cos 2x dx. So I'm going to rewrite the whole expression from the beginning as follows. Page 3. We're saying, therefore, the integral of e to the power x cos of 2x dx is going to be equal to, let me start way back, is going to be equal to, remember where we're at, there is that part there, don't forget that, half e to the power x sine 2x, that part, this is going to be half e to the power x sine 2x, that part has been captured, and then we have minus half I, minus half I. So what is I? Well, I is just what we got here, this expression, the whole of it. So we're going to say minus half e to the power x cos of 2x, and then plus half the integral of e to the power x cos of 2x dx. Right. Now that's what we have. Now let's distribute the minus half. Removing these square brackets, we have the following. I'm going to move down, right, so we have enough space, we can see it clearly. So that's half e to the power x sine of 2x minus half, it's going to be positive a quarter of e to the power x cos 2x. The minus times minus half times positive half is going to be minus a quarter the integral of e to the power x cos of 2x dx. Now notice that this part here, this one here, is just that part there. So what am I saying? What we're saying now is I don't have enough space here to bring that one in that space. Maybe I should try to do that. So basically what we're saying is this implies, and I'm moving back, so integral of e to the power x, and we're saying cos of 2x dx, this is going to be equal to this one here, half of e to the power x sine of 2x plus a quarter of e to the power x cos of 2x minus a quarter the integral of e to the power x cos of 2x dx. Now you see, is this with this part here and that part are basically like terms. I'll add this on both sides, and what we get is the following. We're gonna get the integral of e to the power x cos of 2x dx plus the integral, actually a quarter. Before I go to integral, I'm gonna say a quarter, the integral of, remember this, we're adding on both sides. Here it cancels. On the other side, you must have a quarter of the integral of e to the power x cos of 2x, and then this and that are taken care of like that, and then we have this part is equal to half e to the power x sine 2x plus a quarter e to the power x cos 2x, like that. Nice. Factorize e to the power x here, or basically add these up. Remember, this can be written as a 4 over 4 integral of e to the power x. Remember, there's a 1 outside, so it's just 1 times this integral here. It's just this integral. I'm writing 4 over 4 because I have 1 quarter here, so I can just add the numerators. So cos of 2x dx plus 1 quarter the integral of e to the power x cos 2x dx. This will be equal to half e to the power x sine of 2x plus a quarter e to the power x cos 2x. Now, the left hand side, if you agree with me, is basically 4 plus 1 is 5. So this is 5 over 4. The integral of e to the power x cos of 2x dx. This is going to be equal to that part there. Half of e to the power x sine of 2x plus a quarter of e to the power x cos 2x. Nice. Now we divide by 5 over 4 both sides, each term by that, taking us to page 4. Just to finish this up, what do we have? We have the following. Divide by quarter, divide by 5 over 4. Here you're going to have, and this is our page 4 now, the final page. Let me put this one in the right order. Move it to the left here to be all right. So there we go. Now what I'm saying is, dividing by 5 over 4 here, there, and there, what you should get is, on the left hand side, you should get the integral of e to the power x cos of 2x dx. On the right hand side, you should find half divided by 5 over 4. Do I have a page here that I can use, or I should just take some page at the bottom here? This is what I'm saying now. I'm saying to you that if you take this into itself, you just have 1 and times that, but half 1 over 2 divided by 5 over 4. This is 1 over 2 times 4 over 5, and this is 2 over 5. Remember, 2 goes there 2 times. 2 over 5, so that's what I'm going to have. 2 over 5 of what? E to the power x sine of 2x. And then I have a quarter divided by 5 over 4. A quarter divided by 5 over 4. Which quarter are we talking about? That quarter there divided by that one. Remember, we're dividing, we're trying to make that subject of formula. Remember, where our interest is to evaluate this integral. We divide by that here, there, and there. So this is what we get. Now this is 1 quarter times 4 over 5, and you see the answer is 1 over 5 because the 4's cancel. So what we're saying now is, we're saying plus 1 over 5 e to the power x cos of 2x. But then we have to say plus a constant c. So this will be the final solution. You can do the factorization here, but it's not necessary. You can leave it the way it is, or you can factorize, take out the common factor, factorizing this part here. you can take out the common factor, and the common factor would be, for example, 1 over 5 e to the power x, like this. Some people like to put it in that format. 1 over 5 e to the power x, open brackets. This in there, you'll have 2 sine of 2x plus, take 1/4 e to the power x out, you can have plus cos of 2x, and then plus c finally. So this would be another way in which you present that, but I would like to leave it like that. All right, so this is how you approach it, and tell me what you think about this. Your comments remain very important to us. All right, see you in the next one.